Okay, we're now going to look at derivatives of products and quotients. Okay, so this is going to be examples that involve multiplication and division, so let's just get right into it. Okay, so example 1, f of x equals x plus 7 bracket x minus 2. Okay, so our first move then is to get rid of the brackets, so whatever method you use to do that from National 5, go for it. So for example, FOIL method, if that's one you use, maybe it's not, but if it is, first x times x is x squared, outside x minus 2 is minus 2x, inside 7 times x is 7x, and last 7 times minus 2 is minus 14. So it'll be x squared plus 5x minus 14. Okay, so now that I've got rid of the brackets, it's ready to differentiate. Bring the power down, multiply, take one away from the power, and that's going to be 2x plus 5, and minus 14 will vanish. Example 2. Example 2, I've got f of x equals x minus 7 bracket 3x plus 4. Okay, first x times 3x is 3x squared, outside x times 4 is 4x, inside minus 7 times 3x minus 21x, and the last minus 7 times 4 is minus 28. Tidy up the middle, and it'll be 3x squared minus 17x minus 28. Now differentiate it, bring the power down, multiply, take one away from the power, so it's going to be 6x minus 17 and minus 28 will go. If you've got a different method for expanding out, that's fair enough, just go for it. Example 3. Example 3, I've now got 3x plus 1 bracket x plus 5 bracket x minus 2. Okay, so first move, let's open up the bracket. Now the way I'm going to do this one is I'm going to multiply out these two and then multiply whatever I get by the first bracket. Okay, so I'm going to take those two to the side and do them. X plus 5 bracket x minus 2 will be x squared minus 2x plus 5x minus 10. That'll be x squared plus 3x minus 10. Bring it back in, and it all needs to be multiplied by 3x plus 1. So it's that times that and that times that. First term times the second bracket, and the second term times the second bracket. Okay, so 3x times x squared is 3x cubed. 3x times minus 3x is minus 9x. And then it's 3x times minus 10, which is minus 30x. I've got 1 times x squared, which is x squared. I've got 1 times minus 3x, which is minus 3x. And I've got 1 times minus 10, which is minus 10. Okay, let's tidy this up. That's 3x cubed minus 39 minus 42x plus x squared minus 10. Now differentiate it, and it'll be 9x squared minus 42 plus 2x and minus 10. Well, that's a constant, so when I differentiate it, it goes. Okay, example 4. Example 4, we've got f of x equals x plus 7 all squared. Okay, so that's a repetition of the bracket, x plus 7 bracket x plus 7 will be x squared plus 7x plus 7x is plus 14x plus 49. Now I differentiate it to get 2x plus 12 and 49 will go. Example 5. Okay, example 5, we're going to differentiate x cubed bracket x squared plus 7. Okay, so x cubed times x squared will be x to the 5. And then x cubed times 7 is 7x cubed. Now why is that x to the 5? Well, that's just because when you multiply, you add the powers. Okay, now differentiate it, bring the power down, multiply, take 1 away from the power, 5x to the 4 plus 21x squared, final answer. Okay, example 6. We're going to differentiate the square root of x bracket x squared plus 5. Okay, now first of all, think about it. number there's 2, the number there's 1, so let's get rid of that immediately. That's x to the 1/2 bracket x squared plus 5. Okay, we're now doing that times that and that times that. So we've got x to the half times x squared. I'm just slowing right down with this, plus x to the half times 5. Okay, so what do we need to do here? We need to add the powers. So we're adding 1/2 and 2. The best way to think about this is just to visualise it. So you get half a pizza and you add on the y we're adding because it's rule 1. We're multiplying, which means we add the powers. Half a pizza plus 2 full pizzas. That will give you, if you think about it, it's dead easy, it's 5 halves. And then x to the half times 5 is just 5x to the half. Now differentiate, bring the power down, multiply, take 1 away from the power. And that's going to be 5 halves x to the 5 over 2, take away 1 is 5 over 2, take away 2 over 2, that's 3 over 2. And then a half times 5 is 5 halves again. And then it's 1/2 take away 1, 1/2 take away 2 halves, which is minus 1/2, final answer. Okay, example 7. The square root of x bracket the square root of x minus 7. Okay, square root of x is x to the half, so that's x to the half bracket x to the half minus 7. That times that and that times that. Take your time with it, open it up. It'll be x to the half times x to the half minus x to the half times 7. That's rule 1 indices. When you multiply, you add the powers. So you get half a pizza plus half a pizza is 1 pizza. That's just x to the 1. Don't need to write it. And x to the half times 7 is just 7x to the half. Okay, now I'm ready to differentiate. So if you differentiate x, well, a constant x just becomes a constant. What is the constant? So it's 1x. So if you differentiate 1x, you just get 1. Bring the power down, multiply. A half times 7 is 7 halves x to the minus 1/2 because it's half take away 1, half take away 2 halves, so that's minus 1/2. Example 8. Okay, so example 8, we've got f of x equals the square root of x bracket the cube root of x squared plus x to the 4. First move is to get rid of the root sign, so it's going to be x to the 1/2 bracket x to the 2/3 plus x to the 4. Now I'm going to take my time, expand the thing out, get rid of the bracket. So that's x to the half times x to the 2/3 plus x to the half times x to the 4. Okay, so we're doing rule 1, add the powers. So a half times half plus 2/3. Let's just go to the side and do that. You can use kiss and smile method, so it's going to be 3 plus 4 over 6. That times that plus that times that over that times that. That's 7/6 x to the 7/6. And then I've got, let's visualise this one, half a pizza plus 4 full pizzas. So you eat 4 pizzas plus half a pizza, you've eaten 9 halves. Okay, then after all that work, I still need to differentiate the thing. Bring the power down, multiply, take 1 away from the power. 7/6 take away 6/6 is 1/6. And that will be 9 halves x to the 9 halves take away 2 halves is 7 halves. Okay, example 9. F of x equals 1 over x squared plus x cubed all squared. Right, this is just getting a wee bit trickier, so let's just take our time and see what's the best strategy. Okay, the first thing that I would do within here is bring that up using the fact that a to the minus n equals 1 over 8 then. So I could now write that as x to the minus 2 plus x cubed all squared. So if you're squaring the bracket, you just repeat the bracket. That's x to the minus 2 plus x cubed. Bracket x to the minus 2 plus x cubed. If you're unsure with this one, I can't remember from National 5, just go with FOIL method. Okay, firsts, outsides, insides, and lasts. Okay, firsts, outsides, insides, and lasts. So what we're doing here, we're multiplying things together. So that's rule 1 indices, which means you add the powers. So first move, first, x to the minus 2 times x to the minus 2. Let's just take our time and write it out dead long. Outsides, x to the minus 2 times x cubed. Insides, x cubed times x to the minus 2. Lasts, x to the minus 3, or rather x to the 3 times x to the 3. Multiply, add the powers. Minus 2 add minus 2 is minus 4. Minus 2 add 3 is just 1. Don't need to show it. 3 add minus 2 is 1 again. And then 3 plus 3 is x to the 6. Let's tidy it up. X to the minus 4 plus 2x plus x to the 6. Now I can differentiate the thing, bring the power down, multiply, take 1 away from the power. 2x just becomes 2, and that will be 6x to the 5 final answer. Okay, example 10. Right, example 10, let's go for one over the square root of x minus the square root of x all squared. Just going to take our time with this one again. So it's going to be 1 over x to the half minus x to the half all squared. Okay, so use a reciprocal rule to bring that up. X to the minus 1 half minus x to the half. Let's just repeat that bracket. Then I can use FOIL method, firsts, outsides, insides, lasts. Let's do the firsts. X to the minus 1 half times x to the minus 1 half. Outsides, x to the minus 1 half times x to the half. Insides, minus x to the minus 1 half times x to the minus 1 half, and lasts minus x to the minus 1 half times x to the half. Okay, minus a half plus minus a half is minus 1. Minus a half plus a half is 0, x to 0. Minus a half plus minus half is minus 1 again. And then minus a half plus a half is 0 again. Now remember, from indices, it's starting to pile up the knowledge here, so anything to the power 0 is 1. So I've got x to the minus 1 and x to the minus 1, that's 2x to the minus 1. I've then got something to the power 0, which is 1, and something to the power 0 again, which is 1 again, so together they make 2. Don't forget to differentiate. Alright, bring the power down, multiply, take 1 away from the power, minus 2x to the minus 2, and plus 2 will go. Okay, let's go into some quotients now. F of x equals x cubed plus 5x minus 2 over x. Okay, now the first thing that we need to do is to split this into 3 separate terms. Now, a common move that people make with this question, and it's dead wrong, is to bring that up and somehow say it's that. Doesn't make any sense. Alright, so what you do here is you split it into 3 terms. Okay, so you've got x cubed over x, 5x over x, and minus 2 over x. They two cancel out. Okay, now you're going to use rule 2 indices. A to the power m divided a to the power n. You subtract the powers. Okay, what number's here, even though you can't see it? It's 1, 3 take away 1 is 2x squared. And then you've just got plus 5. Bring that up, minus 2x to the minus 1. Now I'm ready to differentiate. Bring the power down, multiply, take 1 away from the power, 2x. 5 goes. Minus 1 times minus 2 is plus 2x to the minus 2, example 12. F of x equals x plus 9 over x. That doesn't make any sense. Don't go for that. Split up into two terms, that's always your move. X over x plus 9 over x. Anything divided by itself is 1. Bring that up, change its sign, 9x to the minus 1. Now I can differentiate it. The constant goes, so 1 vanishes. And I get minus 9x to the minus 2, example 13. F of x equals x to the 5 plus 2x cubed minus 7 all over x squared. Split it into 3 terms. X to the 5 over x squared plus 2x cubed over x squared minus 7 over x squared. Okay, 5 take away 2 is 3, x cubed. 3 take away 2 is 1. 2x to the 1, that's just 2x, and I bring that up and change its sign. That's going to be minus 7x to the minus 2. Now I can differentiate, so it's going to be 3x squared plus 2 plus 14x to the minus 3. Okay, example 14. F of x equals 9 minus x squared over x to the 5. Split the thing up. 9 over x to the 5 minus x squared over x to the 5. Bring that up, change its sign, 9x to the minus 5. 2 take away 5 is minus 3. Now I'm in a position to differentiate, bring the power down, multiply, take 1 away from the power, minus 45x to the minus 6, minus 3 times minus 1 is plus 3, x to the minus 4. Okay, example 15. F of x equals 6 plus x bracket 9 minus x squared over x to the 4 thirds. Okay, so just a bit awkward this one, take your time. Okay, 6 times 9 is 54. That's my first outside. 6 times minus x squared is minus 6x squared. Inside x times 9 is 9x. And lasts x times minus x squared is minus x cubed. All over x to the 4 over 3, and now I split it into 4 separate terms. So it's going to be f of x equals 54 over x to the 4 over 3 minus 6x squared over x to the 4 over 3 plus 9x over x to the 4 over 3 minus x cubed over x to the 4 over 3. Okay, so it's just a bit messing about with this one. Okay, bring that up, so that's going to be 54x to the minus 4 over 3. Think about it, I need to subtract the powers here. I've got 2 pizzas and I subtract 4 thirds. So in 2 full pizzas you'll get 6 thirds. So you get a pizza, you break it into 3 bits. Okay, so each bit's a third, so you get 2 pizzas, you eat 4 thirds. That's 6 thirds, take away 4 thirds, that's 2 thirds, that's 6x to the 2 thirds. Get a better diagram than that. Okay, now, what number up here is there, even though you can't see it? 1. So you've got 1 pizza, take away 4 thirds, 3 thirds, take away 4 thirds is minus 1 third. And then you get 3 pizzas, take away 4/3, so 3 pizzas is 1, 2, 3, 9/3. 9/3 take away 4/3 is 5/3. If you really take your time and think about it, you still haven't differentiated. That's what you need to do next. Okay, so minus 4/3 times 54. That's going to be minus 216/3. X to the minus 4/3, take away 3/3 is minus 7/3. 2/3 times 6. That's going to be 12/3. But 12/3 is just 4, so that's 4. And then x to the 2/3, take away 3/3 is minus 1/3. You get minus 1/3 times minus 9. So it's going to be 1/3 times 9. 1/3 of 9 is 3, so it's going to be plus 3x to the minus 4/3. Bring that down, that's going to be minus 5/3 x to the 5/3, take away 3/3 is 2/3. Final answer. We won't bother doing any examples at the end of these, just study these ones closely and we'll pick them up in class next day.